السلام عليكم شباب. Here we are in chapter 4, some solved problems in chapter 4, and we have this problem. Let us read it first and then we will try to sketch it. I would think شباب that the best way to solve any physics problem, if we can sketch it, it will be much better. Let us read it first. A pendulum at rest has its bob at 0 height from the ground. The bob is the ball that is attached to the pendulum. If the bob is pulled back until it reaches a height 2.5 meters above the ground and then pushed forward with a speed 2.2 meters per second, that should be the initial speed. What is the maximum speed of the pendulum in meters per second? So I will try to sketch it first. That's the pendulum. So at the beginning, شباب, as it said, the height is 0. The pendulum is at rest, has its bob at 0 height. So now, when it was at rest, the height is 0. So that should be the level of the height. And then it has been pulled back like that, for example. It becomes here. And that height now is 2.5 meters. The new height of the bob is 2.5 meters. Then this ball, the pendulum itself, will be pushed in that direction, will be pushed with an initial speed equal to 2.2 meters per second. That should be the initial speed. And the question is, what is the maximum speed of the pendulum? The maximum speed of the pendulum will be at that position. When this pole now moves to that position, it will be here, have the maximum speed. That's V maximum. And then as it goes in that direction, the speed is decreasing and the height is increasing until it again has a speed equal 0 and the maximum height. كل ده ملناش علاقة بيه. He is asking about the speed, the maximum speed, يعني the speed at that position. اتعلمنا شباب that any problem that has height and speed, the first thing I would think of is the conservation of energy. So we have 2 points here, A and B. Since there is no mention for the air resistance, it would be 0, of course, here, as long as there is no mention for the air resistance. So we consider that the air resistance equal 0. Then the kinetic plus the potential, this is the conservation of the mechanical energy. The kinetic plus the potential at point A equal the kinetic plus the potential at point B. Let us just write the equation. So kinetic plus potential at point A equal the kinetic plus the potential energy at point B. Then we will just write the equations and the values afterwards. The kinetic energy at point A is half mVA squared plus the potential energy at A is mgh1. Let us just call this height as h1 equal the kinetic energy at B is half mV maximum VB or V maximum squared plus mgh2, the height at position B. Let us just look at the values. VA equal 2.2 meters per second. HA equal, or H1, let's just call it H1, it doesn't matter يعني. H1 equals 2.5 meters and H2 equal 0. So this equation شباب will be a little bit changed when we just substitute with the values. It will be half. Now, of course, we can also cancel out them. This with that, with that, with that. And this value from the beginning is 0 because H2 is 0. then this equation turned to be half VA squared يعني 2.2 squared plus G 9.8 times H 2.5 equal half V maximum squared. And from this equation you can get easily how much is V maximum or V maximum squared. Solving for V maximum, you can work it out yourself. It will be almost 7.34 meter per second. We have another question, this time about the work done, and it states the following. A force F 5 Newton is applied on an object to move it from one point to another point. The horizontal component Fx and the vertical component Fy of the force are described as Fx equal 4 Newton and Fy equal 3 Newtons. So it looks like this force is not in the X or in the Y. It is something in between, like that. For example, here we have F, which is 5 Newton, and it has been resolved. تحللت لتو components, Fx 4 Newtons and Fy 3 Newtons. Okay? If the object covers, the object is going to move now. In which direction the object is going to move? The problem states that the object covers a displacement of that value along the y-axis. The object is only moving in the y-axis. How much joules of works is done on the object by the force F? Of course, one of the most common mistakes of some of the students, they will just say that, well, we have F equal 5 and the distance traveled is this distance, so it's this time that, here we have the work done. And of course this is totally wrong, because the shabab, simply the work done is the force times the displacement. Yani the object must be moving in the same direction as the applied force to have a work done. So I would say something else. I would say if we have, let us just forget about this force now. We have two forces. خلاص, it has been resolved and it's finished. And عايز أعرف Fx and Fy, the effect of Fx and Fy on the object. Wx, the work done in the x direction, equal Fx times dx, the distance traveled in the x direction, times cosine theta. In principle, this is equal 0 for a simple reason. dx equals 0. عرفت منين يا شباب? How did you know that the distance traveled in the x? Because it doesn't mention that. It only said that the object is moving in the y direction, so there is no x direction in the motion. Since dx equals 0, wx also will be equaling 0. Now we're gonna find the work done in the y direction. wy equal fy dy cosine theta. Fy is 3 Newton. dy is that distance 288.49 times cosine theta. In this case, the object is moving, the force in that direction, and the object is moving in the same direction. Theta will be 0, and cosine 0 equal 1. So that should be 1 in this case. And we have the final work done is almost something around 865.5 joules. And that should be the total work done by the force F. Shabab, this is the work done by the total force F. You might say it's only by Fy. أقول لك صح. It's only by Fy, but Fy now will represent F. لأن Fx will never do any work. These problems combines the efficiency with the mechanical advantages. A system of pulleys has an efficiency of 70%. That should be E. And a mechanical advantage of 19. This is the MA. a mechanical advantage. How far? He's asking about the distance in meters. That's the distance. You should pull the rope downwards in order to lift the load that has a load 2.4 meter upward. We are using a system of pulleys, not one. We have many of these pulleys, okay, in some way, and we have a rope here and there. We have an object like that. How much the distance that you need to pull it down, this rope down, how much is that distance, the input distance? Is asking about dn for the load to be lifted up a distance 2.4 meter. This is d out. So I have confirmed now that he's asking about dn and we have d out. How to solve such problem? I would just write the equation of the efficiency at the beginning. I would say efficiency E equal W out by W in. And we don't have the work done, but we have force and distance. I would say it's F out times D out over Fn times Dn. The problem is we don't have even F out and Fn, but we have the mechanical advantages. Look at that, شباب. The mechanical advantage also, if we just write it down, write everything that you know here يا شباب على الهامش كده. قول mechanical advantage is the efficiency is. The mechanical advantage is, I think, it's F out by F in. I think it's clear. We can just remove this part now and we can put the mechanical advantages instead. So the efficiency would be having, I would say, a new know now, right? New formula. E equal, the efficiency equal, the mechanical advantage, that's meant this part, multiplied by D out by Dn. Now I think it will be clear. Remember, we are looking for Dn. Do we have the other things? Yes, we have the efficiency. The efficiency is 70%, yani 0.7. The mechanical advantage is 19 times. D out is 2.4, and we are looking again for Dn. Solving 2.4 for Dn, Dn equals something around 65.14 meter. This is a good problem. Another problem, شباب. A car is traveling at 13 meters per second. Okay, that's the speed. How fast in meter per second would the car need to go to double its kinetic energy? So the question, شباب, the question is about how much is the speed, the new speed, that will make the kinetic energy to be doubled. So I will solve it in a simple way. I would say that let us just calculate the first kinetic energy for the car that moves, for the car when it moves, because we are talking about the same car. When it moves with 13 meters per second, the kinetic energy, let us say Ke, the kinetic energy is half, and m, the mass, times v squared. Let us say that it's 13 squared. Okay, 13 squared. This is the kinetic energy. Now, the speed will change and the kinetic energy will double. So let us say that when the speed became, this is the first case, and in the second case, the kinetic energy will be doubled. So it will be 2 kinetic energy to this value. Is it still equaling half m 13 squared? No. That will be half m, and for the new speed that we will call it as v. When the speed changed from 13, of course it should be increasing again, from 13 to v, اللي هي unknown بالنسبة لي, it will be v. The kinetic energy became double, as I said. So our job, our task is to find how much is that v that will make the kinetic energy doubled. So I will just play with this equation. I will leave this one as it is. Let us just play with this one. I will just take this 2 to the other side. It will be down here. So Ke, I'm talking about this equation now, will be 1 over 4. This 2 will be في المقام تحت شباب numerator it will be 1 over 4 mv squared. So look at this equation and that equation, they are equal. So we can say that half m 13 squared equal 1 over 4 m v squared. The mass, this 2 plus 4, we have 2, and now half v squared equal 13 squared. These 2 will go on to the other side. V squared equal 2 times 13 squared. So V equal the root of this value, the root of that value. The root will, let us say that it's the root of 2 times 13 squared. That equals root of 13 squared will be 13, تطلع برا 13 شباب, and 2 will stay inside. So the value of the V that will make the kinetic energy be doubled is 13 root. And of course we can just solve it out, we can sort it out. How much is that? I think it's a kind of maybe 18.38 meter per second. So if the speed of this car, of the same car, change it from 13 meter per second to 18.38 meter per second, the kinetic energy will change from kinetic energy to double the kinetic energy. We'll be having doubling the value. This problem is for the power شباب. Let us just try to read it carefully. An electric pump is used to lift water from a river to a tank that is 13.5 meter above the river. So we have the river here شباب, and we have a pump, kind of pump that lifts the water from here into a tank. This tank is almost 13.5 meter above the river level. The pump transfers 12 meter cube of the water to the tank in 21 minutes. Be careful about the minutes, about the units يا شباب. Okay, and remember, this is the volume, this is not the mass. We are not normally dealing with the volume, we need to convert it to the mass. If the efficiency of the pump is 69%, that's the efficiency AE, because of course this pump will consume some of the electrical energy. We have power in, that should be electrical energy, and we have power out, that should be the power out of, this is the power that will enable this pump to lift this water from here to there. Okay, the efficiency is 69%. Calculate the input electrical power. We need to find this one, the electrical power consumed by the pump. How much the power that will be consumed from the power to lift this amount from here to there. To solve this problem, I would first find P, and there should be P out, the power out of this pump, الخارجة منها. So B equal, this is the symbol below, W over T, and the work done by the pump now is just mgh. So it's mgh divided by the time. Do we have the mass? No, we have the volume. But remember, he gave us some hint here. بيقول لي in 1 cubic meter of water has a mass of 1000 kilogram. So 12 meter cube is 12,000 kilogram. That should be the mass in this case. The mass of this volume is equivalent to 12,000 kilogram of water. So the mass is 12,000 kilogram times 9.8 times 13.5 divided by the time. But remember, we have to change that from the minutes to the second. It should be in the second. So it will be 21 times 60. How much is that, شباب? I think it's a kind of 1000 260 watts. This is the power out of this pump. The question, I will say this is power out, is for power in. How to get power in? We have the efficiency, شباب. We have tried the efficiency. The efficiency E equal, look at that, W out by W in. لسه برضو ما ظهرتش ال P in وال P out. But I will just make a small change here for this equation. وده من حقي. Look at that شباب. I will just divide this by T, and at the same time I have to divide this also by T. And this will change a little bit. W over T is the power, but it's W out. So it should be in this case P out, and that should be P in. So we have a new law. You can say something like that. The efficiency that you get used to be W out by W in. With a smaller change, now it's also P out by P in. The power out of the machine divided by the power in. طبعا الباور in اللي هي consumed electrical energy. And the efficiency is 69%. That would be 0.69 equals power out, the thing that we have just found now, 1260 watts divided by the power in that we are looking for, and from this simple equation we can find Pn equals, I think it should be in this case, of course, it will be over 0.69, something around 1826.1 watts. One more problem, شباب, about the conversion between the kinetic and the potential energies, or the conservation of mechanical energy. A block is released from rest at a height of 20 meters to slide along a smooth ramp. Ramp يعني inclined plane. It looks like that. شباب, sketching the problem will help us. This is the inclined plane. This block will be released from here on this smooth. Smooth means there is no friction forces. How much is the height? That should be the height in this case. The height would be 29 meters. It will release and it will be moving down. Okay. After reaching to the bottom here, the block will not stop. It will continue move in the X direction, the horizontal. It will continue moving here along a horizontal rough surface. We have a rough surface now. يعني يحصل له deceleration. It takes 8 seconds on the rough surface to stop. So T equal 8 seconds for this block to stop here. يعني V final equals 0. The question is, how much is the distance you traveled in the horizontal direction? How much is that distance? How to solve this problem? We need to find D. Right. I will start from the beginning. It was here and it now there. We have 2 points. Let us just call them 1 and 2. The highest point of the ramp and the lower point of the ramp. Since there is no friction force, so I can say easily again, شباب, that the kinetic plus the potential here equal the kinetic plus the potential there. Let us try to write this equation. So half m v1 squared plus mgh1 at point A equal half m v2 squared, the velocity or the speed here, plus mgh2, the height at this point. And let us sort it out. First, v1 is 0 because he said at the beginning it is released, يعني starts from rest. وحتى لو start from rest. So v1 is 0. So this term will be cancelled. And since h2, the height at point 2, is also 0, that term also will be cancelled. So we have mgh1 equal half mv2 squared. M goes with this m. So gh1 equal half v2 squared. From this we can get how much is the velocity here at this point, at the end of the ramp. So v squared equal to gh1, or v2 equal the root of 2gh1 equal the root of 2 times 9.8 times 29. This will give us, you can just work it out, a kind of 23.84 meter per second. That's the speed at point B. Then it will continue moving in that direction of the force. As long as we have a rough surface, يعني the speed will not be the same, will not be constant. يحصل deceleration وهتقل لغاية after 8 seconds it will be 0. So we can consider شباب, this velocity or this speed here is the initial in the horizontal يعني equals to 3.84. And then we can use this simple equation if you want to find the distance, and you have the initial, v final, and the time. D equal half v initial plus v final multiplied by the time. So should be in this case half v initial is 23.84 plus 0 multiplied by 8. That should end up with a distance of 95.36 meters.